For our next three queries, we're going to switch to the terrorist dataset that we had used in a previous demonstration. Our first query involves finding the types of a particular node. So as you may recall, in the terrorist dataset, there were node types corresponding to a country. So in this case, we want to match all nodes where the name is equal to Afghanistan, and we will return the labels for that particular match. And the results for this query are relatively simple. The label for the node named Afghanistan is country, as you might expect. Next, we're going to do something similar, but with an edge. In this case, we want to find the label of an edge associated with a node named Afghanistan. And also, if you can recall from that particular network, the label for an edge associated with the country named Afghanistan would be an is-from label. And the final query we would like to demonstrate with this terrorist dataset involves finding all of the properties of a node. Now, based on how we defined our data import script, we defined all of our nodes to be of type actor. So in this query, we're going to search for all nodes of type actor, and then we're going to return all of the properties associated with those nodes. But since there are thousands of nodes, we're going to limit the results to the first 20. So let's go ahead and submit our query. And here are the results. Each node represents a terrorist, and if we look at the rows data behind the scenes, we can see the various properties associated with each node. Each node has a name, each node has aliases, one or more aliases, and they have a type property. Now, depending on how we defined our import script in the first place, these nodes could have different types of properties. In this case, we only defined them to have 3 different properties. For our next 2 queries, we're going to use a different data set. It's a biological data set consisting of genetics data representing interactions between genes. We will be providing the data for you to download. In fact, there are 2 separate data sets. One is a complete data set consisting of 250,000 rows, and the other data set consists of the first 50,000 rows. And that's what we'll be using for this demonstration. So let's take a look at a small sample of the data. Here you see a graph network in which each node is a gene and each edge represents the association between genes. To load this data set, this is the smaller data set, required 1,446 seconds, and it consists of 9,656 labels and 46,621 relationships. So the first query involves finding loops in the data which represent genes that have associations with their own types. So it's a very simple query in which the source node and the target node are the same, and we'll be returning those along with the edges, and we'll limit our results to the first 10. So here are the results of our query. We can see a few different loops. If we look at the rows, our query returned not only the node, but the edge type. So on the left, we see the particular gene, and on the right, we see the type of association, and there are a range of different types. So this data set also contains multigraphs. If you recall from a previous lecture, the definition of a multigraph is any 2 nodes which have 2 or more edges between them. So in this case, we'll be matching 2 separate node-edge relationships, and we'll apply a constraint in which the edges must be different for the same pairs of nodes. And then we will return those nodes and those edges. And we'll limit our results to the first 10. And here's the results. Here we see a set of 4 genes, and there are 2 pairs that have 3 edges between them and another pair that has 4 edges between them. Our final query addresses something that has not necessarily been fully covered in previous lectures, but it's useful enough to address here, and you'll get an understanding of it by going through this query example. We're going to essentially extract a subset of nodes and edges from the graph that we've been working with. And this is called an induced subgraph, in which if we provide a set of nodes, we want to return the network that consists only of those nodes and their associated edges. So my first line of code is very familiar. We're matching nodes and edges. It's a very basic node and edge match. The second line of code is where the constraints are explicitly stated. Our resulting network must consist of edges in which the source node must be constrained to this subset of node labels, and the target node must also be constrained to be a part of the subset of nodes with just these labels. And then we return the nodes and the edges. So let's see the resulting graph. And here it is. So as we would expect, we're seeing the 5 nodes that were defined in our query constraints and the edges corresponding to them retain the network structure. So this concludes our review of some of the basic queries you can do with Neo4j using the Cypher scripting language.